Hello and welcome to another episode of Slam TV. I'm Professor Roger Yang, and today we're going to learn about hypothesis testing, part 1. Luckily for you folks at home, we've got a very special guest for you. He's training to be an American Ninja Warrior. He's a former lemonade mogul and is currently an expert kombucha barista. He's Professor Joe.
Thank you, Roger.
Hey Jay, how's it going?
Pretty good. I just got a new career, making big bucks.
What? You got a new job? You mean you're not doing the kombucha barista thing anymore?
No, I decided to pursue my new dream.
Oh, really? What's your new dream job?
First of all, it's a career, not a job. Second of all, I decided to get a job, career, that actually involves statistics.
No way. That's like the perfect job, career for you. You love stats. You practically live and breathe stats.
And I make stat videos too, you know?
That's right. So what led you to this life-changing decision?
Well, I wasn't too happy with my other choices, so I took PCC career survey online. I made an appointment with counselors in our building.
Oh. Did you know that counselors are available Monday through Friday? They can help you in a few different ways.
Yes, I did, Roger. You can make an appointment, you can drop in without an appointment, and you can get help online by filling out online counseling form.
You can do all of this and more by visiting pasadena.edu/counseling. So what did your counselor say?
Well, she mentioned that my interest is in data analysis and critical thinking. She also mentioned that there's a certificate program that directly leads into employment.
Oh, really?
I know, isn't it great?
Wow. It seems that utilizing the student services at the college is super useful.
For sure.
So what exactly is your new dream career?
Well, I'm going to be an HTI, Hypothesis Test Investigator.
What the heck is an HTI, Hypothesis Test Investigator?
Well, I'll be basically testing a bunch of different claims by using inferential statistics. Right now, I'm just learning basic methodology.
Oh. What kind of different claims can you test, Jay?
Well, you can test different kind of claims. For example, we can test a claim about population mean, mu.
Oh, you know what? I was just reading this article, and it was saying that insufficient sleep can lead to poor performance in school.
Ooh.
And I was thinking, man, so many of my students are sleep deprived. Can we test the claim that students sleep less than 7 hours a night?
That could explain why they are so tired all the time. This is a claim about population mean because basically we are saying on average, students sleep less than 7 hours a night. Symbolically, we can write it as mu is less than 7.
Why did you use mu instead of x bar?
Because mu is symbol for population mean. Here, we're testing claim about population mean.
Oh, what other types of tests can we do, Jay?
We can test for population proportion P.
Why don't you remind our viewers of what proportion means again?
Population proportion is a portion or percent of a population with some characteristic.
Oh, so we could test the claim that more than 40% of Californians speak a second language?
Exactly. More than 40%. 40% is a proportion. You can think of it as number of people who speak second language divided by the number of total Californians.
Oh.
Do you speak a second language, Roger?
Of course I do. English is my first language, and I speak math as my second language.
Oh, get it.
Do you speak a second language, Jay?
No.
So, was it the percentage sign that told you that we had a proportion here, Jay?
Exactly. More than 40% translates to P greater than 0.40.
Why did you use the symbol P?
Well, P is used for population proportion.
Oh. What other types of claims can we test, Jay?
Well, we can also test claims about two populations.
Bear alert? Man, you're always on your phone. Wait, can we test the claim that adults spend the same amount of time on their phones as kids do?
So you think adults and kids spend about the same time on their phones? I don't know about that. Those whippersnappers, they're always on their phone. We need to figure out how to measure how much time people spend on their phones.
We could use screen time to check that.
Oh, screen time. That's a great way to measure how much time people spend on their phones. Roger, Are you on your phone a lot? Roger?
It's like Heidi doesn't even know I exist, man.
Claim. Adults spend the same amount of time on their phones as kids do. mu1 is equal to mu2.
What's mu1 and mu2?
Because we have two populations now, we need a notation for each one of them.
Oh, so mu1 could be the mean screen time for adults, and mu2 could be the mean screen time for those young whippersnappers. I mean kids.
In this screen time example, looking at the mean screen time for adults and mean screen time for kids, there are two populations, right? So in this case, we call it test for means with two independent samples.
Oh, and they're called independent samples because one of your samples is kids, and one of your samples is adults. And in theory, they don't have anything to do with each other?
Exactly, that's why it's called independent samples.
Does that mean that there's a dependent samples case?
Oh, why? Yes, I'm glad you asked. Yeah, those type of situations called matched pair.
Oh, so like, how does the matched pair situation work?
Well, this is where two samples are dependent and they're matched in some ways.
Is there a classic example?
Sure, a classic example would be like before versus after situation. For example, like testing for effectiveness of a diet.
Oh, so like, it's dependent because you just have one person and you're measuring their weight before and after.
Exactly, that's why it's called dependent.
Hey Jay, are you thinking about going on a diet?
Diet? What?
Well, when you look at you from the side, you kind of disappear because you're so skinny.
No. What are you suggesting? A keto diet?
Not a keto diet, a kilo diet. You need to add some kilos to that skinny frame of yours. You need to eat a carb and gluten enriched diet.
Ew, okay. Well, in order to test the effectiveness of that, we need to collect sample of people and we have to measure their weight before the diet and after the diet. And we can test for the effectiveness of statistical significant difference, if there's the difference.
Wait, what do you mean by a statistically significant difference?
Well, it's a pretty big deal. Some books calls hypothesis testing test for significance.
Oh, maybe you can remind our viewers or tell our viewers what statistically significant means.
A result is statistically significant if the probability that it occurs purely by chance is extremely low.
Extremely low, purely by chance? What do you mean by that?
Let's say we have a sample of 100 people, right? And they gain on average half a pound.
Using our kilo diet?
Exactly. Do you think that's unusual?
Well, people's weight fluctuates a lot throughout the day. Gaining half a pound or losing half a pound throughout the day, I think that's totally normal. That's not unusual at all.
Right. And also with our kilo diet, what if those 100 people gained average of 10 pounds? Do you think it's unusual now?
Gaining 10 pounds, that's not so easy to do within a single day. I mean, there's people that are on all these crazy diets just to gain a few pounds.
I know.
If this kilo diet is successful, we could be rich, rich, rich. Anyways, are you saying that if they gain a little bit of weight, it's not statistically significant? But if they gained a whole bunch of weight, then it is statistically significant?
Well, it's not necessarily about how much weight you gained. It's about the probability that gaining that much purely by chance is extremely small.
Oh, so it's actually all about probability.
That's right.
Okay, cool. So we can test claims about the mean and claims about the proportion of a single population. We can also have two population tests for the mean, one for independent samples and one for matched pairs. What about comparing two proportions?
Well, we can test claims about proportions involving two populations as well.
Oh, so could we test the claim that young people believe climate change is a big problem and that they're more likely to believe that it's a big problem than older people are?
It is a big problem.
I heard that there's a giant island of plastic twice the size of Texas in the middle of the ocean.
Well, I heard that it was 3 times the size of France. In this case, our claim is young people are more likely to believe climate change is a big problem than older people. This translates to P1 is greater than P2.
What's P1 and P2?
Since we have 2 different populations, we again need a notation for each one of them. So you should specify population 1 is kids and population 2 is older people. So in our case, P1 is proportion of kids who believe climate change is a big problem, and P2 is proportion of adults who believe climate change is a big problem.
Wow, those are a lot of different types of claims. You're going to be in school for like an eternity.
Actually, the basic structure for this testing is pretty much the same. We learned this major methodology, and once you learn this methodology, then for different type of testing, we just have changed a little detail here and there.
Oh, what's this type of testing called?
This methodology that we're going to learn is called hypothesis testing.
Oh, that's why you're called a hypothesis test investigator.
Exactly.
So let me get this straight. You're learning this methodology called hypothesis testing, and you basically use statistical techniques to prove that claims are true.
Proof is not exactly that.
It's not?
Right, we can't prove anything definitively. We can use sample data to look at like what data suggest. For example, we can't say students sleep less than 7 hours a night on average, but we can say that data suggests that students sleep less than 7 hours a night on average.
That kind of sounds like you're saying maybe.
Maybe, but it's more than maybe. It's a strong maybe. It's a maybe with evidence.
So, like, what are some of the conclusions that you can actually say from a hypothesis test?
We can say the evidence suggests that we reject the claim, or we support the claim, or there's no conclusion.
Oh, so the test could be inconclusive?
Exactly.
You get paid the big bucks to basically say maybe. How much are you making again?
Actually, I'm not full-fledged a hypothesis test investigator yet.
Oh, you're not?
I'm doing internship right now as I go through the program.
Oh, well, maybe next episode you could share what you may or may not have definitively learned.
Definitely.